Here's some help with measuring zones of inhibition. First, what is a zone of inhibition? A zone of inhibition is the area around an antibiotic disc where microbes couldn't grow. On this diagram on the screen, if the antibiotic discs are those gray circles, the white circles around them, where no microbes could grow, are the zones of inhibition. The zones of inhibition tell you how effective an antibiotic is at killing microbes. The bigger the zone of inhibition, the more effective the antibiotic was in killing the microbe. So, when you measure these zones of inhibition, you want to measure them through the center, from the top to the bottom, and you want to measure them in millimeters. So you'll take your ruler, make sure you use the metric side of it. It might be in centimeters. You just want to convert it to millimeters. 1 centimeter is 10 millimeters. Measure from the top to the bottom. So here the zone of inhibition would be the area in red there. Now just to compare, let's compare that zone, measuring that zone of inhibition with the zone of inhibition for the antibiotic disc in the bottom right. Take the ruler, make sure you're measuring it in millimeters, and then through the center, you can see the zone of inhibition there. Now notice this zone of inhibition is smaller than the previous zone of inhibition, which means that the antibiotic on the bottom right was not as effective at killing the microbe on this plate as the antibiotic in the top right. So this is the concept of what we're doing. What this looks like live would be like so. Now notice at the bottom right, you have that sort of clear area around the antibiotic disc, and that's where microbes in the confluent lawn couldn't survive. So they died. So that's its zone of inhibition. Compare that with the zone of inhibition much smaller in the top right, and the antibiotic discs on the left don't have any zones of inhibition. They were completely ineffective at killing that microbe. So the reason why you want to measure these in millimeters is because on the interpretive chart that you have, that tells you exactly how susceptible or resistant each species is to each antibiotic, the numbers, so the numbers in the 3 columns on the right, those numbers are all millimeters. So you want to make sure you measure the zone of inhibition in millimeters so you can compare it with this chart. So this is likely to be the type of ruler that you would use. Notice it has 2 sides. The top is inches. That doesn't even exist. Inches are not relevant. We want to use the metric side. Now this metric side is in centimeters. The 1, 2, 3, 4 at the bottom, those are centimeters. 1 centimeter is 10 millimeters. And each of the small lines in between those, in between the 1, 2, 3, each of those small lines is a millimeter. So we're going to use that metric side to measure these zones of inhibition so that we can compare it with the chart. So for example, live, we'll line that up here through the center from one end to the other. And you can see here, the zone of inhibition on this one would be around 29 or 30 millimeters. So 3 centimeters, but 29 or 30 millimeters. Here again, through the center, from one end to the other, it would probably be around 11 millimeters. And so that would be how you measure zones of inhibition, using the millimeter side of a ruler through the center of the area where microbes didn't grow. The larger the zone of inhibition, the better the antibiotic was at killing those microbes.